Geometry, Chapter 3, Circles, Module 9. In this module, we'll solve sums on problem set 3, the second part. Question number 2. Line L touches a circle with center O at point P. If radius of the circle is 9 centimeters, answer the following questions. So the first question is, what is distance between OP and Y? Second is, if distance OQ is 8 centimeters, where does the point Q lie? Third, if DOR is equal to 15 centimeters, how many locations of point R are on line L? At what distance will each of them be from point P? Let us start with the solution. Segment OP is the radius of the circle. This is given in the question. And distance OP will be 9 centimeters as it is the radius. The second part is, here 8 centimeters is obviously 8 is less than 9. So distance of OQ will be less than distance OP. So we can say that distance OQ will be less than the radius, as OP is nothing but the radius of the circle. So point Q lies in the interior of the circle, as the distance between O and Q is less than the radius. So point Q should lie inside the circle. The third part is, there can be two locations of point R on line L. It could be on the right hand side of point P or on the left hand side of point P. Now it's given distance OR is 15 centimeters. Now in triangle OPR, by tangent theorem we can say that the radius OP will be perpendicular to the tangent L. So OPR is 90 degree. We'll use Pythagoras theorem in the triangle, and OR will be the hypotenuse. So we can say OR square is equal to OP square plus PR square by Pythagoras theorem. OR is 15, distance OR is 15 and OP is 9 centimeters. That's the radius of the circle. We substitute the values, take the square of 15 and 9. So square of 15 is 225, square of 9 is 81. We'll simplify this, we'll take 81 on the other side, so we'll get PR square equal to 225 minus 81, which is 144. Now we'll take square root on both the sides, and we know square root of 144 is 12 centimeters. So the length of PR is 12 centimeters. Question 3 of problem set 3. The question states, in the adjoining figure, M is the center of the circle and segment KL is a tangent segment. If MK is 12, KL is 6 root 3, we have to find what is the radius of the circle, and second, measure of angle K and angle M. Solution. Line KL is a tangent to the circle at point L, and segment ML is the radius. This is given to us. So we know by tangent theorem the radius has to be perpendicular to the tangent. Therefore angle L will be a right angle. Hence we can say that angle MLK is equal to 90 degree. Now if you look in the triangle MLK, we know that MLK is equal to 90 degree, and since it is 90 degree and MK will become the hypotenuse, so we'll use the Pythagoras theorem that says MK square is equal to ML square plus AL square. So we know that MK in the question it is given 12, we'll substitute it. Similarly, AL in the question is given as 6 root 3, we'll substitute both the values. Square of 12 is 144 and the square of 6 root 3 will be 108. So we'll take the 108 on the other side, we'll get 144 minus 108, which is 36. So we'll take square root on both the sides. So ml is equal to square root of 36, and we know that square root of 36 is 6 units. Therefore, radius of the circle is 6 units. We know that ml will be half of mk, and k, angle k is 30 degree. By converse of 30, 60, 90 degree, the side opposite to 30 degree is half of the hypotenuse. So similarly, we can say that by converse, we can say that if side opposite to hypotenuse is half, if ml is half of the hypotenuse, then angle k has to be 30 degree. Now, if you look in triangle MLK, angle L we know is 90 degree, angle K is 30 degree, and M has to be 60 degree. Question 4 of problem set 3. In the adjoining figure, O is the center of the circle. Segment AB and AC are tangent segments. Radius of the circle is R. Length of AB is equal to R. And we have to prove that quadrilateral ABOC is a square. So it is given, let us write what all is given to us. O is the center of the circle. Segment AB and segment AC are tangents to the circle with center O. Radius is R. Also, length of AB is equal to R. We have to prove quadrilateral ABOC is a square. So for that, we need to do a construction. We'll draw segment OB and segment OC. If you see in the figure, we have drawn OB and OC. Let's start with the proof. Segment AB and segment AC are the tangents to the circle. This is given to us. And AB is equal to AC, because we know by tangent segment theorem that states tangent drawn from an external point are equal to each other or congruent to each other. So AB is equal to AC. But AB is given to be R, and since AB is equal to AC, AB and AC both will be equal to R. Also, OB and OC, if you see, they are the radius of the circle, and in the question it is given that the radius of the circle is R. Therefore, OB and OC both should be equal to R. Now, since from 1 and 2, we can say that AB, AC, OB and OC, all of them will be equal as they are equal to R. So AB equal to AC equal to OB equal to OC. Now, since all of the sides are equal, quadrilateral ABOC is a rhombus. But angle OBA will be 90 degree by tangent theorem. As tangent theorem states that the radius has to be perpendicular to the tangent. So angle OBA will be 90 degree. Therefore, quadrilateral ABOC is a square, because we know a rhombus is a square if one of its angle is a right angle. So in a rhombus, if you know that one angle is a 90 degree angle or a right angle, then that rhombus will be a square. So proving one angle is 90 degree is more than enough to show that the quadrilateral ABOC is a square. Fifth question of problem set 3. In the adjoining figure, ABCD is a parallelogram. Quadrilateral ABCD is a parallelogram. It circumscribes the circle with center T. In the figure, if you can see, it circumscribes the circle with center T. Point E, F, G, H are touching points. If AE is 4.5, EB is 5.5, we have to find the length AD. Let's start with the solution. Let the value of DH and CF be X and Y respectively. So we'll say DH to be X and CF to be Y. AE equal to AH equal to 4.5. If you see AE equal to AH and both of them are 4.5, because we know by tangent theorem, tangent that are drawn from a point outside the circle will be equal or congruent to each other. So AE will be equal to AH, and if AE is 4.5, AH should also be 4.5. Similarly, BE will be equal to BF by the same concept. Tangent drawn from a point outside the circle will be congruent to each other. So BE will be equal to BF, and since BE is 5.5, BF should also be 5.5. Similarly, we have considered length of DH to be X. So by the same concept, DH will be equal to DG and both of them will be X. And similarly, CF will be equal to CG and both of them will be Y. This all by tangent segment. So if you see AE 4.5, AH 4.5, EB and BF both 5.5, DH and DG both X, and CF and CG both Y. So it is given quadrilateral ABCD is a parallelogram, and AB is equal to CD as opposite sides of a parallelogram. AE plus BE, if you notice, AE plus segment AB is formed by AE plus EB. Similarly, CD is formed by DG and CG. So in place of AB, I'm substituting it as AE plus BE, and in place of CD, I'm substituting as DG plus CG. AE is 4.5, we'll substitute it. BE is 5.5, DG is X, and CG is Y. So we'll just add this. 4.5 plus 5.5 is 10. So we get X plus Y is equal to 10. We'll call this as equation 1. Also, if you see, AD and BC will be equal as opposite sides of parallelogram are equal. So we can do the same thing. So in place of AD, we can write it as AH plus DH equal to, and in place of BC, we can write it as BF plus CF. Substituting the values, AH is 4.5, DH is X, BF is 5.5, and CF is Y. Just rearranging this will bring the variables on one side. So we'll get X, and if we take this plus Y on the other side, it will become minus Y. And if we take this 4.5 on the other side, we'll get 5.5 minus 4.5. So the equation that we get here is X minus Y is equal to 1. This is equation 2. Now we'll solve equation 1 and 2 simultaneously. So we'll add them first. If we add, we get 2x equal to, so this plus y and minus y gets cancelled. X plus x will give me 2x, and 10 plus 1 will give me 11. If I solve this, x will be equal to 11 by 2, which is 5.5 units. We can substitute the value of x in any one of the equation, either in equation 1 or in equation 2, to get the value of y. Also, we know AD is AH plus DH, and we know that AH is 4.5 and DH, that is X, we got it as 5.5. So we just substitute the values. So AD will be equal to 4.5 plus 5.5, which is 10 units. So AD is 10. So this is the problem set 3, the question number 6. In the adjoining figure, circle with center M touches a circle with center N at point P. Radius Rm touches the smaller circle at S. Radii of the circle are 9 centimeters and 2.5 centimeter. Find the answer to the following question. Hence, find the ratio Ms is to Rn. The first question is find the length of segment MT. Second is finding the length of segment MN. And third is finding the measure of angle NSM. Let us solve this question. Solution: MT is equal to 9 centimeters, which is given in the question. That is the radius of the bigger circle. MT will be equal to Mn plus Nt. So in the diagram, if we join segment MT, it will pass through the center of circle N. So circle with center N, and MT will be equal to Mn plus Nt. MT is 9 centimeters and NT is 2.5 centimeters, which is given in the question. So if we take this 2.5 on the other side, we'll get 9 minus 2.5. So Mn will be 9 minus 2.5, which is 6.5 centimeters. So length of segment Mn is 6.5. So let us move on to the third part. In the third part, we have to find the angle NSM. Now we know that segment MR is a tangent to the smaller circle and NS will be its radius. Therefore, by tangent theorem, we know that the radius has to be perpendicular to the tangent. Therefore, angle NSM will be 90 degree. And in the fourth part, we have to find the ratio. So we'll start in triangle NSM. So if you note in the diagram, triangle NSM, angle NSM is 90 degree. By the previous part we found out. And since it is a right angle triangle, we can use Pythagoras theorem. If we join Mn, Mn will be the hypotenuse. So by Pythagoras theorem, Mn square is equal to Ns square plus Ms square. Mn is 6.5 and Ns is 2.5 square. So we'll just square this 6.5 square and 2.5 square and just rearrange it. We'll take 2.5 on the other side. So we'll get Ms square is equal to 6.5 square minus 2.5 square. So we'll just use here to simplify it. We'll use the formula a square minus b square, which is a minus b, a plus b. So we'll just use this a minus b, a plus b, a minus b. So this will be 6.5 plus 2.5 into 6.5 minus 2.5. So 6.5 plus 2.5 is 9 and 6.5 minus 2.5 is 4. And 9 into 4 is 36. We still have to take the square root. So square root of 36 will be 6. So length of MS is 6 centimeters. But if you look at the diagram, MR will be equal to MS plus NR. MR equal to MS plus SR. And we know MR is 9 and MS is 6. 6 we have just found out. So to find out NR, we'll just rearrange this. We'll take 6 on the other side. So we'll get SR is equal to 9 minus 6. So 9 minus 6, which is 3. So SR is 3 centimeters. We have to find out the ratio MS upon MR. MS we got is 6 and MR is 3. So 6 upon 3, if we reduce this, we get 2 upon 1. So the ratio MS upon MR is 2:1.